And welcome back again for the final installment in Chapter 5, 5.6 Guided Notes, Moon Phases. So there's some data about our moon here at the top. It's about 1.2% of the Earth's mass, 27% of the Earth's diameter. It's usually about 340 or 384,000 kilometers away from the planet, from our planet. Time for one rotation is about 27.3 days, and time for one revolution is 27.3 days. That's why we always see the same side of the moon. Now, as mentioned before, gravity has about about 1/6 that of the Earth. So a 120-pound human would only weigh 20 pounds in the moon. So why doesn't that man in the moon ever go away? Well, the same side of the moon is always facing us. That side is called the near side. The other side is called the far side of the moon. And in this picture, which is slightly off, it shows that because the moon is spinning at the same rate that it's revolving around the planet, we always see that same side. So if a person was standing on it, we would always see them in the same position on the moon. Now, some vocab to know. Waxing. Waxing means growing or getting bigger. So the light is on the right. Now, waning would be shrinking or getting smaller. The light is on the left on those. A crescent moon is less than half illuminated. So a crescent would be half or less, so generally less. So the ones on the far right, you have a waning and waxing crescent. Now a gibbous is more than half illuminated. So gibbous is like a waxing or waning gibbous on the left-hand side where you can see more than half of the moon. Moon phases. So here you can see, going around the picture, you can see the first quarter, second quarter, first quarter goes to full, then you got the third quarter and new. Okay, and here you see the picture again. You can see where the moon is in relation to the Earth, and you can see where it would be in relation during the different phases. So in the first one with the new moon, we would see no light because it is basically all dark on the part we're seeing. And then as it's rotating around, we start to see more and more. We start to see a waxing crescent, and then we see a half moon, then we see a waxing gibbous, and then a full moon. And then as it starts to go around to the other side, where we don't see quite as much, we start to see it wane. So we see a waning gibbous, and then we see a half moon, then we see a waning crescent, and then again we're back to the new moon after about 27.3 days. So where is the sun in relation to the Earth? Here you can see the different images. Over on the left, you can see the sun on the left-hand side, and then what we would see and how we would see it, and why we would see a half, why would we see a crescent, why would we see the full. And on the right-hand side, you see it flipped around. Eclipses. A solar eclipse occurs when the moon passes between the Earth and the sun, so it actually blocks out the sun's light, leaving a moving region of shadow on the Earth's surface. And if you're right in the middle of it, you can actually see the moon go directly across and cover up the entire sun. A lunar eclipse occurs when the Earth passes between the sun and the moon, casting a shadow on the moon. And you can see that in the picture on the right, where it looks like the moon is really dark. That's because the Earth is getting in the way of the light from the sun. Now, these are things that would be a good idea to draw because they show how a lunar and solar eclipse works. So on the top, you can see the sun is hitting the Earth, and the Earth is blocking out the light, and the moon kind of has that reddish appearance. It still gets a little bit of light, but not anywhere near enough, so it makes it look kind of dark. Now in a solar eclipse, the moon passes between the sun and the Earth and creates a dark area on the Earth, and if you're right in it, it will get very dark. And that is something called, you have the umbra, which is if you're in the darkest area, and then the penumbra, which is the area that you can see part of the eclipse. You'll see it block out part of the sun. Total versus partial lunar eclipse. So a total lunar eclipse is when the entire moon passes through the Earth's umbra. That's the dark area. And a partial is when only part of the moon is passing through. So you'll get kind of a, partial eclipse. Here on the left, you see the solar, and on the right, you see the lunar. So here's some practice that you can do. You can go back to some of the previous images and see if you can figure out what you would have in different spots. Where would the sunlight be coming from? What should you see, etc., etc. So things to take away from this last section. One is, what is an eclipse, a solar eclipse? What is a lunar eclipse? And how do the moon phases work? So what is a waxing gibbous, a waning gibbous, a waxing crescent, and a waning crescent? What is a full moon, and what is a new moon?